Hi everyone, warm welcome to B.Tech. Today we are going to discuss about a subject named fluid mechanics and hydraulic missions. As a part of this subject, we are discussing about hydraulic missions. So in hydraulic missions, let us discuss reciprocating pumps in today's session. Let us see the definition of reciprocating pump. So reciprocating pump is a positive displacement one which works on the principle of reversing a piston motion within a cylinder, drawing in liquid during forward stroke and delivering it under pressure during return stroke. So what it will do, it will draw liquid in forward stroke. Drawing means it will suck the liquid in forward stroke, and when it is coming to its initial position, that is in return or backward stroke, it will deliver the fluid. The principle used in this reciprocating pump is single slider crank mechanism. Okay, so what happens in that is, see simply here, so we will have a cylinder like this and we will have a piston like this. So what will happen, this is the scenario, so we will have a connecting rod which is connected to something crank like. So what will happen now, if we see here, so what will happen, so this piston will reciprocate inside this cylinder, inside this fixed cylinder. Okay, so during forward stroke, or else we name it as a suction stroke, we will suck the fluid from the sump or storage tank and we will deliver it to the delivery storage tank. This is what we do in the reciprocating pump. So if we see here, so this is my cylinder and having a piston inside it, and to this cylinder two pipes are there. Bottom pipe is known as suction pipe and the top pipe is known as delivery pipe. Okay, and if you see, the cylinder and piston is connected to the connecting rod, okay, with the help of a piston rod, right, and this connecting rod is connected to crank. So what will happen in this principle, whenever this crank is rotated, so the rotation of the crank will cause the linear reciprocating motion to the piston. So rotary motion to sliding motion, this is the principle of single slider crank mechanism, right. So who will run this crank? We will generally run this crank with the help of some electrical motor, right. So whenever this crank is rotating, the piston will also reciprocate. So if the piston is moving towards this side, that is towards the crank end, we name it as suction. During this motion we will suck the fluid. When the piston is moving from crank side to other side, so it will move in this direction, that is from right to left. So this is known as a return stroke or delivery stroke. During this, the piston will send the fluid into the delivery pipe, right. So let us see some main parts of the reciprocating pump right now. So the main parts of the reciprocating pump are, so as we just seen, it has a cylinder with a piston, of course a piston rod, connecting rod and a crank wheel, right, and apart from this we will have a suction pipe, delivery pipe and their respective valves, that is suction valve and delivery valve. Let us see each part clearly and neatly. Suction pipe. What suction pipe will do? The suction pipe connects the source of a liquid to the cylinder of the reciprocating pump, right. So the liquid is sucked by this pipe from the source to cylinder. So it is like inlet pipe. Okay, right. What is suction valve? So suction valve is a non-return valve, NRV valve. See, the function of non-return valve is it will allow the flow of motion in one direction only. It will not allow the flow of motion in other than the given direction. That is the function of non-return NRV valve, right. So suction valve is a NRV valve, which means only one directional flow is possible in this type of valve. This is placed between suction pipe inlet and cylinder. For example, let us take, this is my cylinder. I had a suction pipe at this position, like this, it will be at the bottom position. So we will have an NRV valve right here. So the function of NRV valve is it will allow the motion of the fluid in one direction. That is, we will take it from the sump, generally we name it this as sump. We will collect the water or the fluid from the sump or reservoir and we will deliver it to the cylinder. So NRV valve will allow motion of the fluid in this direction only. Other than this, it will not allow, right. Next, delivery pipe. So the delivery pipe, what it will do, it will connect the cylinder to the delivery part, that is outlet part or tank, the part where we use this pressurized water. The application of any hydraulic pump, any pump is, it is used to give the pressure energy to the water, right. Next, delivery valve. Of course, delivery valve is also a LRV valve and it will always lie between cylinder and delivery pipe outlet, right. Next, cylinder. What is cylinder? So as we know well, cylinder is a hollow member Generally it is made up of cast iron or cast steel. So arrangement of piston and piston rod is inside the cylinder. So your cylinder will consist of, right, for example, if my cylinder is like this, right, so this is my piston, okay, and we will have piston pin here, and to this a piston rod is connected, and this piston rod is again connected to connecting rod. So this is how your piston and cylinder looks like. So this is your cylinder, let us name it as C, and this is our piston P, right. So, and what will be there to this suction and release? Suction and release of liquid takes place in this. So sucking of the fluid from the sump and delivering of the fluid to the discharge tank or application where we use these two are taking place with the help of this cylinder piston only, right. Next, piston and piston rod, that was discussed right now only. So what it will do, the piston will reciprocate. So reciprocating motion of piston will cause successive suction and again delivery, right. Next, crank and connecting rod. So the crank and connecting rod are used in the reciprocating pump. The reason is we have to transfer the power from crank side to the piston side. So who will do this? We will have a crank like this, right. So the crank is a circular member, it will rotate, and this rotation of the crank is transferred, this rotation most of the crank is transferred to the piston with the help of a connecting rod like this. So this is how we have connecting rod, and this connecting rod is generally connected to the piston rod. This is how it looks like, right. So the reciprocating motion of the piston is obtained from the crank and connecting rod only. So the connecting rod will act as a coupler or a mediator link between the crank wheel and the piston, right. Next, strainer. So strainer is nothing but a substance like a filter. It is generally fixed at the bottom of the suction pipe because we can't say the sump where we connected the suction pipe. In sump we can't say that there is neat of water, that is we can't say that there is clean water. There may be some form of debris, there may be some form of waste. So to filter these things we generally use strainer, right. Strainer is nothing but a filter, right. Next, air vessel. So the purpose of air vessel is to create uniform discharge or uniform flow rate inside the reciprocating pump. So the application of air vessel we will clearly see in the upcoming topics. As a part of now, please remember that air vessel is used to create uniform discharge rate, right, and we use air vessel at suction pipe and also at delivery pipes. So these are the some important parts of the reciprocating pump. Let us see the classification of reciprocating pumps, right. So on the basis of contact of water, that is if the water is on only one side of piston, then we name it as single acting cylinder, and if the water is on two sides of the piston, we name it as double acting cylinder. Let us see it clearly. If water is in contact with one side of the piston, the pump is called single acting pump. In case of single acting reciprocating pump, there will be only one stroke in half revolution of the crank, and second stroke will be done in second half revolution of the crank. That means we have a crank like this, right. So this is connected to your cylinder. So let us take this as cylinder and this as piston. So now what is happening? Now my piston is at most left side, right, and the position of the crank is here. So whenever the crank has rotated a half revolution, that is the crank has rotated 180 degrees. Let us assume the crank has rotated 180 degrees. So now the crank position is here. So this is nothing but half the revolution of crank. So in single acting reciprocating pumps, whenever the crank has rotated 180 degrees, the piston will move from left to right. So the piston will be here. At this position the piston will be here, right. So half revolution of the crank, half of the crank, this will happen, right. So and what will happen here? Generally suction stroke will take place, that is cylinder will suck the fluid from the sump, right. And what will happen in another 180 degrees rotation? Again the piston will move from again most right side to most left side. It will move from right to left. Another half revolution of the crank will take place here, and this is generally your delivery stroke. So what he is going to say is there will be one stroke in half revolution of the crank and another second stroke in another half revolution of the crank. So for first half one stroke and for second half one stroke, right. It will happen in single acting reciprocating pump. Hence in case of single acting reciprocating pump, there will be one suction stroke and one delivery stroke for entire complete revolution of the crank, right. So what happens in double acting cylinder? If water is in contact with both sides of piston, then the pump is named as double acting reciprocating pump. See, there will be a suction stroke on one side of piston At the same time, there will be delivery stroke on the other side of piston. That is, if you see in this diagram, see, this is the right side diagram is the representation of a double acting reciprocating pump, right? So if you see here, in the left side, water is there. Okay, let us mark water with this dashed part. So on left side we had water, and right side also we had water. So what will happen? For example, let us take the piston is moving from left to right. So this is your left, this is your right. So when the piston is moving from left to right, what will happen? At the left part of the piston, suction is taking place, and in the right side of the piston, delivery will take place. Okay, so this is what will happen. So simultaneously, in one single stroke only, at one part suction is happening and another part delivery is happening. If you see, in half the revolution of this crank wheel, 2 strokes will take place. That is thing we will see here. See, hence in case of double acting reciprocating pump, there will be 2 suction strokes and 2 delivery strokes for one complete evolution of the crank. So 2 strokes will take place for one complete evolution of the crank. That will have total 2 plus 2, 4 strokes will take place for one complete evolution of the crank. And for half revolution of the crank, 2 strokes will take place for one complete evolution of the crank. 4 strokes will take place. That is 2 suction strokes and 2 delivery strokes. So this is what happen in double acting reciprocating pump, right? And let us see the classification of the reciprocating pumps based upon number of cylinders. So there may be a single cylinder pump, double cylinder pump and multi-cylinder pump. If the cylinders are 2 or more than 2, usually we name it as double cylinder pump, right? So what happens in single cylindrical pump? A reciprocating pump will have only one cylinder, okay? And single cylinder pump can be either a single acting or maybe double acting also, right? And what happens in double cylinder pump? In double cylinder pump will have more than one cylinder, okay? Like it may be 2 pump, that is 2 cylinders, 3 pump, that is 3 cylinders, 3 throw pumps. So more than will be there, and your crank settings will be like it will be 120 degrees, right? Because of multiple cylinders. So this is how the single cylinder and multi-cylinder pumps will work. So in the coming session, we will discuss about the working of the reciprocating pump. So thank you for this session. Thank you.